Hi, I am here to give the video presentation on IPC. So IPC, it stands for inter-process communication. So I can say this is a very significant concept we have in QNX. So basically we know the QNX, it uses a microkernel architecture. Here we'll be having, as the name implies, so the kernel, it will run the necessary functions in the kernel space. All other remaining functions like file system management, network stack, so these functions will be executed as a separate process in user space. Okay, so the file system management, memory management, and communication protocol stack will be executed as a separate process in user space. So we cannot say like the OS, it is a big one big program and which is going to take care of everything. No, so we'll be having many smaller programs which are all need to be coordinated together for the successful of whole functions. So I can say this IPC, it makes the microkernel as a unified whole, so that all the processes will be communicated each other. Okay, so as we have some functions which are like very independent and which are executing, but still, in order to communicate between several processes in the user space or proper synchronization among them, we are using this IPC. So without this IPC, I can say like all other functions will be executed independently, but there is no synchronization. It is not cooperative. So I can say this only this IPC, it makes all the processes coordinating together, and it makes all the processes cooperative. So because we cannot we cannot have it like one process, it shares its memory directly to another process. Okay, so what it will do, it uses IPC. Okay, whenever it wants to communicate, it uses IPC. So in that, this messages basically like it will be having a payload, and suppose if I have taken the client server model, so whenever a client wants to communicate with a server, then it sends message sender. If the server is receiving the message, it sends a message received, that is from the server to the client. If the server acknowledges back to the client, then it sends a message reply. Okay, so this is so these are all the ways of IPC, inter-process communication, in case of QNX Neutrino. So messages, signals, pulses, shared memory. So in that messages, like it will share the payload, and as I said before, and in case of pulses, okay, these are like fixed messages. Okay, the kernel will be issuing this pulses. Okay, to notify that a timer has expired. Okay, whenever timeout occurs, then it tells that so the timeout has occurred. Okay, then this signals, basically like it is a lightweight message in case of IPC, and it wants to convey something. Signals, as the name implies, it wants to notify that a particular event has happened. Okay, so like we can say this IPC is a very significant concept in case of QNX microkernel architecture. So as it makes the OS as a unified whole. So basically this IPC, then also another thing I can say, like whenever it uses messages, okay, it uses channel create, okay, then connect attach. So these are all the two commands which is being used in case of messages, IPC messages. So the server, it establishes a channel, so that a client, whenever it wants to communicate, then it sends connect attach. So it get connected to that channel, because in order to communicate between client and server, there needs a channel in between. Okay, so for this QNX Centrino, it uses these two commands. So these are all the basically this signals and pulses are the lightweight messages we have in case of IPC. So the I can say I can at last I can conclude IPC is very very important, so that all the process like we'll be having different functions. They are very independent. It will be executed independently, but in order to make it synchronized together, so it needs there needs an IPC. Okay, so it plays a very major role in QNX. Thank you.